So this is a question on the making of aspirin. So there's 2 samples of aspirins that have been made, and aspirin has been made using salicylic acid and ethanoic anhydride. So there's 2 samples, and this is the mass of salicylic acid used, and this is the mass of ethanoic anhydride used, and this is the mass of aspirin obtained for sample 1. Sample 2 used 2.06 gram of salicylic acid, this mass of ethanoic anhydride, and produce this mass of aspirin. So you need to find for each samples 1 and 2, you need to find which is the limiting reagent in each case. So you do this by finding the number of moles of salicylic acid here, finding the number of moles of ethanoic anhydride here, and then based on the number of moles you deduce which one is the limiting reagent. Do the same thing for the second sample. Then you calculate the theoretical yield of aspirin in both cases. So based on the number of moles of limiting reagent, you will know how much aspirin you are expected to get according to the equation. So you're going to use the same equation as here. So based on the equation, you can see that 1 mole of salicylic acid reacts with 1 mole of ethanoic anhydride to give 1 mole of aspirin. So it's 1:1:1. So which means that limiting reagent to aspirin content is also going to be 1:1. So you find the theoretical mass of aspirin that you're expected to get. And then you find the percentage yield. So percentage yield is how much you got over how much you were expected to get times 100. And also based on the method to obtain the product and based on the melting point, you can comment on the purity. So I would like you to pause the video, try to work out this question, and then you come back to it once you're done. So for part A, you're going to find the amount of moles of reactants by both samples. So we're going to work on sample 1 first. So number of moles would be mass divided by MR. So for sample 1, I found the number of moles of salicylic acid and the number of moles of ethanoic anhydride based on the mole ratio 1:1. So I find that salicylic acid is found in the least amount. So this one is the limiting reagent. I will do the same thing for sample 2 here as well. So number of moles of salicylic acid is less, so this is going to be the limiting reagent. So in both cases, salicylic acid is the limiting reagent. Now to find the theoretical yield, we're going to use the mole ratio. So 1 mole of salicylic acid is going to give you 1 mole of aspirin. So we're going to use the number of moles of salicylic acid in each case. In sample 1, so this is the number of moles of salicylic acid. This is going to give you the same mole of aspirin. Then from this, you can get the mass of aspirin, which is going to be the number of moles times the MR, which is 180.17. So this is the mass of aspirin that we were supposed to get in sample 1. So this is the mass of aspirin that I'm supposed to get in the second case. Now from this, I can find the percentage yield in each case. So for case 1, I was expecting 3.35 gram, but I only got 2.11 gram. So this is going to be the percentage yield. And for the second sample, I was expecting 5.03 gram, but I only got 3.42 gram. So this is going to be the percentage yield. So in the first case, percentage yield is 63%, and in the second case it's 68%. However, when we look at the melting point, this one has a melting point which is closer to the melting point of pure aspirin, and you can see in sample 2 the melting point is lower than that of pure aspirin. The range is a little bit wider, so this has range 2 and this has range 1, so it's melting a little bit over a wider range, but the main visible effect is that the melting point is lower than the actual melting point of aspirin. Sample 1 has a lower yield, however, it is more pure since it melts at a range closer to the melting point of pure aspirin. And even if sample 2 has a higher yield, it has a much lower melting point range in comparison to that of pure aspirin.